let's put in some numbers to the system that we have described just now. Okay, so let's say our hotter region here is 100 degrees Celsius and our colder region over here will be 0 degrees Celsius. In that case, we set our temperature to be fixed at both ends. So we call this both end here as heat reservoir. And now because of that, we can say that for our left end of the rod, the temperature will be maintained at 100 degrees Celsius. For the right end of the rod, which has a length of L, the right end of the rod will have its temperature being maintained at 0 degrees Celsius. Okay, so we have a uniform rod. When we say uniform rod, that means by the area of the rod remain constant along the rod. You won't see regions that are fatter, you won't see regions that are slimmer. The cross-sectional area of the rod is uniform throughout the along the rod. Okay, and the material is the same material, yeah, with length L over here. So you place this rod over here to allow these two regions here to be in thermal contact. So now we are interested to see how does the heat transfer happen through conduction. Okay, when we take this rod over here and place it inside this system, the rod initially is in room temperature, right? Okay, so what we should assume in the first place is that the rod should start off at 25 degrees Celsius throughout the whole rod. This is what happens initially. Your rod has a temperature, a uniform temperature of 25 degrees Celsius, which is the room temperature. Okay, but as you place this rod inside, in between these two regions over here, what happened is your hotter region here, it's hot. So because it has a higher temperature than 25 degrees Celsius, heat will transfer from the hotter region over here to the rod. Again, there's temperature difference. Here is 100 degrees Celsius. The left end of the rod is 25 degrees Celsius. Hotter, colder. Because of that, there will be heat transfer from the hotter region to the left end of the rod. So when you receive that amount of energy, what happened is your left end of the rod will experience an increase in temperature. It will get hotter and hotter for the left end over here. Okay, on the other hand, if we shift our focus to the right end of the rod, the right end of the rod is 0 degrees Celsius, which is colder than 25 degrees Celsius of this end of the rod. Here is 25 degrees Celsius, here is 0 degrees Celsius. Hotter region for here, this is the colder region. 25 is greater than 0, so the right end of the rod is hotter than the colder region over here. Because of that, we know that heat will transfer from the right end of the rod to the colder region over here. So heat will transfer from here to here. Now, because there's heat transferring out from the rod, you know that the right end of the rod will experience a decrease in internal energy. So that means it will get colder. So what happens is the right end of the rod will experience a decrease in temperature, whereas the left end of the rod will experience an increase in temperature. So because of that, when you place the rod in between these two regions over here, what happens is the temperature will start to change something like this. You experience something like this. Then at a later time, you see that the temperature change further. Then you see that at some point, it'll be something like this. Then at the end of your at some point, you see that the temperature will stabilize. Okay, the temperature will stabilize at a certain pattern, and once the temperature of the rod has stabilized, then we say that the rod has already entered steady state. Okay, that's the idea of steady state. Initially, the temperature along the rod is changing because you just introduce them to a new temperature on both ends. So the temperature along the rod will be changing. So when it's changing, right, we say the rod is not in steady state. But once the temperature has already settled down along the rod, the temperature is no longer changing along the rod, then we say that the rod has already entered steady state. Okay, so this is how it sort of looks like. You change its temperature until it stabilizes at a certain temperature. Then once it has stabilized at a certain temperature, which is around this moment over here, we say that the system enters steady state. Okay, so that's the idea of steady state. The main concern that the main message that I want to deliver here is what is steady state? It's a state in which the temperature has already settled down along the rod and the temperature is no longer changing with time. Okay, so that's the idea of steady state.